Okay. Um, it takes a little while, like, because the video has to process and blah 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 blah. So and if I have another
Mhm.
client, it might take a bit. So but usually within an hour or so it's available.
Okay.
It's better than Netflix, isn't it? Okay.
Yeah. Thank you
Right.
so much for recording it.
Like, hey, I'm gonna watch my math tutoring session again. Okay, so log base 2, cube root of 27 is 3 squared, right?
Yeah.
You okay with that?
Hmm.
And would you immediately write 9, or would you write step by step? Just curious.
I would write 9.
Okay, well, I'll just write the steps this one time. So log base 2 of 9 plus log base 2 of 32. Now, there is also a rule, and I'm going to get rid of this one, and it is not here. It's not on this little sheet, but I'll put it on for you. That log base a of a to the x is equal to x. So if your base is the same as the argument, the logarithm is equal to the exponent,
Hmm.
which makes sense if you think about going to exponential form, because you would go a to the x power equals whatever is here, right? Or equals. So what happens if I went to x, it means a to the x equals a to the x, because that's the whole thing in here, right?
Hmm.
So it's equal to whatever this x is. So we have that right here. So we can say log base 2 of 5 if we wanted to. Now it looks to me like, did you copy this down to your teacher from your teacher's notes?
No, this is homework that I did on my own.
Okay, so right now there's nothing further you could do to simplify this, right?
Hmm.
Um, the other way to go, I'm going to say wonk, or log base 2 of 9 times 32 using that rule equals log base 2 of 288. And either solution should make your teacher happy.
Hmm. I
Um,
put log base 2 of 88.
288. Yeah,
Yeah.
I would think either one would make, is it
Yes.
him happy?
Okay. All right. That makes so much more sense because he didn't show us that rule of when you have that exponent or when you
Yeah,
have that number in front,
right.
it goes to the exponent. Because
Yeah,
he showed it to us, but he didn't show us like the general rule. Like you used m as exponent and then plugged m into the front.
right,
So
right.
visualizing with any number that makes sense now.
Yeah. And then this one right here is very, very helpful. The same base and the exponent, it's always equal to the exponent.
Yeah.
Yeah. And anytime, you'll have these notes here, but if you just Google rules of logarithms, and you get nice lists that are nicer than my sort of adding to this list here. So, all right, what do we got next?
Okay. The next page that I sent you was the back of homework 5.
Okay, I got it.
Um, and then taking a quick look at number 18,
Mm-hmm.
it says log base like fraction with the square root of y over 4y plus 8.
Mm-hmm.
And then I divided it by 2. But I don't really know where I got the 2 from.
I don't either. Um, yeah, actually, I think I know. I see. Okay.
because I'm looking at it and I realized that I wrote log y minus 2 log y plus 8.
Yeah, there's a lot going on with this one. So I'm gonna write it step by step, okay? It looks,
Okay.
it's, looks to me like you're a really good math student who can see things and not have to write out every step, which is fantastic. But I'm
Mhm.
going to write out steps here, okay? So
Okay.
just to be sure. So this is y to the 1/2 over 4y plus 8, right?
Right.
Okay, so we have a division dealio, which means I can use this guy right here
Yeah.
and rewrite this as log y to the 1/2 power minus log of 4y plus 8. Is that okay?
Yeah.
Okay. So now we're going to use this guy again, but the other way. We're going to take the exponent and move it out front because the directions were to expand it as much as possible.
Oh, okay. So
Is that
I
okay?
took it and then I multiplied it by 2 to get rid of that fraction.
Yeah,
I divided it by 2.
correct. And then you can factor out a 2 here, which I could have done in that step. In fact, I'll go ahead and do it because again, you're smart enough to see it.
Mhm.
So it's log of 2 times 2y plus 4. So did I do that right? Yep. Okay, so we got a
Yeah.
multiplication thing going on here. I guess I don't really need these parentheses, which means we can then say minus log 2. It's multiplication, so it's log 2y plus 4. And we should
Okay.
distribute the negative, I guess. You did not. I'm not sure where you got the 2 log 2. So 1/2 log y minus log 2 plus, or not plus, minus log 2y plus 4. You have a 2 right here.
Yes, because I think I divided the 4y plus 8 divided by 4, and
Oh,
then
I
I
see.
split it into 2. Like I did 2 and 2.
I think
So
that's
I gave
illegal.
each log.
Oh, I thought you saw the 1/2 and put this 2 in the denominator.
I may have.
But what you dividing by the 4, you can't, or the 2. So I think what you're saying, correct me if I'm wrong, is you took log, oops, you took log 2y plus 4 and did this, or 2y,
And then divided it by
or
2 again.
I'm sorry, 4y plus 8. Is that right?
Yeah. Yes.
Well, you can't, like, this 2 cannot divide the 4y plus 8 because you would have to take the log of it first before dividing it.
And then divide. Okay.
Yeah, that's a illegal move.
Okay. So my answer was wrong.
Correct. It's wrong.
Okay. And then when you divided it by 2, could you have also divided it by 4?
Yeah, well, yeah, if you had a better tutor, then he would have done that.
Because I think that's what I may have done. I may have divided it by 4
Oh my
and written
God.
2 because I took 2 of each.
Okay, so that, yeah, I'm so sorry. I don't know why I did that. So that's 4 times y plus 2, right?
Yeah.
Okay, so let's hold on. So that turns into log of 4 and y plus 2, right?
hmm
And then log 4 y plus 2. And let's see what you have. No, you still can't divide. You can't divide anything within the logarithm that's outside the logarithm.
Okay, yeah, I missed that step.
Yeah.
Okay, I think that was it for that page.
Okay.
And then another thing, like I said at the beginning, with the graphing, that was from homework 6, which should be the next page.
Yep, I see it.
That one I also got mixed up on the what to divide by and what have x equal what numbers.
I see. Okay. So do you want to pick out a particular one?
Number 2.
Okay. So. And did he have you use tables?
Yes, he's requiring us to use tables.
Okay. So it is the inverse of the exponential function, the logarithmic function, and you already see the basic shape. I see. But just, do you know what I mean by that? Like the graph of the logarithmic, and so it's a reflection in the line y equals x. Are you good with that?
Yeah.
Okay, so let's see. All right, so we'll go x and y here. So y equals 2 log base 1/4 to the x. So y equals 2 1/4 to the x. I'm trying to think of the best way to pick numbers for x, and I think that's what you're getting at, right?
Yeah. He says we have to do -2 to 2.
Oh, you have to do that. Oh, for y?
For using the x values as -2 to 2. Yeah.
Okay,
For
but
y.
oh, for y, yes. Okay, because that's what you have. Okay. All right, sorry. So -2, -1, 0, 1, 2, because I was wondering why you divided by 2 right away, but now I see, because you choose y values, not x values. Okay, so
Right.
so then y over 2, this is cool, equals log 1/4
That way
of,
log is by itself.
yeah, log
Okay.
1/4 of x. And then, you can, it's not too terrible then, because, let me move this down. So we tried 2, right? So when y equals 2, I'll just put it off to the side here. Y equals 2. Would you agree that 1 equals log base 1/4 to the x?
Yeah.
Okay, so then you just go to exponential form, which is 1/4 to the first power is equal to x. So x equals 1/4. Does that make sense?
Yes. Because then that's what you get for the 2 value.
Yep. And then you keep on going. So I'll go a different color, not to get them mixed up. So then, let me put that above. Okay, so this is for y equals 2, right? And so now if we do y equals 1, then we get 1/2 equals log base 1/4 to the x. And do you agree that 1/2 to the 1/4 power is equal to x?
Yes.
So that's the 4th root of 1/2. Actually,
It would be 1/4 to the power of 1/2.
oh, sorry.
Or no.
Yeah, why did I do that? As I was looking at it, I was like, oh, well, that's easy. And then I wrote it the wrong way. So 1/4 to the 1/2, right? Well, what's 1/2 equal to? Or like the exponent of 1/2 is just the square root, right?
Right.
So the square
Of
root of
1/4.
1/4 is 1/2.
1/2.
Is that good?
Yes.
Okay.
And
So
then you
then,
just keep plugging in the y's for whatever your y values want to be.
absolutely. And then you just work it out.
Okay.
You want to keep going?
No, I think I got that one.
Okay.
And then could we do number 3?
Number 3. Yep. And so this one, you're going to pick values for x for sure, right?
Yes.
And this is no calculator? No, there's a
This
calculator for
one, we're
sure.
allowed to use a graphing calculator,
Yeah,
but it won't give you like the exact point, if that makes sense.
yeah, it makes total sense. Is that okay? Or do you have to get the exact point?
No, you just have to get the decimal.
Oh, okay,
I think 3 places, 3 or 4 places.
okay. So, hopefully that's not a huge deal. So, and he tells you those are the values you have to pick?
The basic ones are -2 to 2, but
Okay,
then if you want to use other values to help you figure out where the graph will eventually go,
uh-huh,
then he also recommends adding some more points.
okay. So basically, we're finding f of -2 equals negative natural log of -2 plus 5, right?
Hmm.
So that's just negative natural log of 3, right? So then we just crank
Right.
it in our calculator. And that's where you got the -1.099.
Yes. But then if you look back at like the homework that I did, he makes us write it into an equation where x equals whatever, and then you plug in y as those numbers.
Okay, so then so we're gonna make this a y, right?
Right.
Okay, I'll just rewrite it like that. Y equals negative ln of x plus 5. Need to get that negative out of there. So I'm going to say negative y equals ln of x plus 5. Is that okay?
Yes.
Okay, so then we're going to go to exponential form and we would get e to the negative y equals x plus 5.
Correct.
And so e to the negative y minus 5 is equal to x.
Got it.
So,
And then you just plug in the y values.
so then I'm sorry, you have to use the y values for from -2 to 2 and find the value and
Yeah.
find the corresponding of x's. Oh, okay. And you did the opposite on your sheet. You didn't do it how he wanted you to.
Yes, I think I flipped up the X and Y.
Yeah, which makes sense between you and me.
Because when he writes it, he writes Y on the side of X and then X on the side of Y. So I
Oh,
naturally wrote it opposite, but then me thinking logically, X goes on the left side and then Y goes on the right side. So I
gotcha.
just mixed up the sides, I guess.
Gotcha. Okay. You okay?
But then when I plug it into my calculator and I put E to the negative Y, I don't get the number.
So in your calculator, it should be E,
So if I
and
were to
then
use the
you
value
need
of,
to be -2, and then -5. So you're not gonna get -1.099. Or wait a second. No, hold on. E,
because I plugged it in and I get 2.3891.
yeah, because it's different. It's the inverse. You're switching the X's and the Y's. So 2.389, right? So let's double check that. Control C. And so negative natural log control V plus. Yeah, it works. So if you plug in 2.389 into this equation right here, you get -2 for Y.
Okay, got it.
Okay.
Yeah,
It's not going to work the same way. Like we were plugging something different in for X, right? It's not going to correlate if that's what you were thinking.
right.
Yeah.
Okay. I just didn't know how to switch it, like
Yeah.
the equation, how to
Yeah.
put it from Y equals to X equals.
Yeah. But now you see the exponential form and it's not too terrible.
Yeah. And then let me see which other one I sent you. I think I sent you my homework 8,
Okay.
which was I think number 8 was the one that I was confused on.
Okay. What are we doing here? Solve each equation, check for extraneous solutions. Okay. This might be the last one. We're coming up on, I got a student coming in at 4.
Okay. If we have to cut it short, it's fine. I just don't understand the first part of it.
Okay. Well, this is on the left side. This is the form of log A plus log B equals log AB.
Right.
Okay. So and they all have the same base, right?
Hmm.
So this would be log base 8 of W plus 12 times W, right?
Yes. And then
Equals, and what rule can we use?
the circle rule.
No, over here on the right, I've got a 3 in front of the log. Where can I move that? It can become the exponent.
Yeah.
You remember that?
Now I do.
Okay. And which is wonderful news because I have the log of, if I have the same base, right?
Mhm.
Then the arguments must be equal if the logarithms are going to be equal. So
Right.
W plus 12 is going to equal 64 and we're off and running, right?
Yeah.
16 and 4. I'm not, how good are you at factoring?
Yeah, I understand it.
Okay, so then you have to be careful. Because you cannot take the logarithm of a negative number.
Right, so then you cross out the 16.
Yeah. Now, sometimes a negative will work. Plugging in a negative will work. Case in point, you know, like if, for instance, you can plug in some negative numbers into this logarithm here, right? Just as long as the result isn't negative within the parentheses.
Right, and then for the one that we were working on, if you plug negative 16
Yeah,
plus 12, then you get negative 4.
yeah, can't be done.
And but then if it was a positive number,
You-
and then you would add it to the 12, that would also give you a positive number. And then would you multiply that by the W? Like, would you multiply it by another positive number?
As far as
Or
checking
does
it,
everything in the parentheses have to equal a positive?
yeah, no. You take each individual one. This must be positive on its own, and this must be positive on its own.
Okay,
Because if you had a negative here and a negative here, you know, if you multiplied them, you'd get a positive. But no, it has. You have to look at the original equation.
okay,
Okay.
got it. I think that may have been it.
Anything on the next page?
Let's see, page 9.
This is going from exponential to logarithmic form.
Right, and then you just take the log of each and then divide the logs on both sides.
Yeah, and you're using your exponent rule, which looks like you did here. You just didn't know you were doing it.
Right.
Yeah.
Could we go over number 6?
Sure. Looks like you did a change of base. That's 4a. So first thing we do is add 9, right?
Right.
So 13 to the 4a is equal to 5, right?
Yeah.
What I would recommend is using this rule. Log base a of a to the x equals x, right?
Mm-hmm.
So to solve this, I clearly have to take the log of both sides. So I can
Right.
use any base I want. So since the base with the exponent in it, the base is 13, I'm just going to take log base 13 of 13 to the 4a and take log base 13 of 5. And the reason I'm going to do that is immediately log base 13 of 13 to the 4a equals 4a. And then all you have to do is divide by 4. And we learned how to put a different base in your calculator. And you're done.
And then, okay. Because what I got was I got log of 5 divided by log of 13 divided by 4.
That's fine. This is just quicker.
Okay. I see. Yeah.
Yeah, it's the same. It's the same thing. You use the change of base rule.
Got it. And then, yeah, I just plugged it in my calculator and I got the same answer.
Yeah. Yep. There's,
Okay.
you know, it's like there's different ways to solve equations. There's different ways to solve logarithms. This is much more efficient.
Okay. Thank you so much.
You're welcome. And I will post the recording as soon as I can. I got another student, so it might take me a little bit. Okay.
Okay.
All
that's no
right.
problem.
Nice to
Thank
meet you,
you so much.
Megan. We'll see you next week.
Bye. Yes, I will have my dad text you.
Okay.
Okay.
All right.
Thank
Bye-bye.
you.
Yep.
Bye.